yawning status. So when the vehicular approach, steering wheel, lane detection, and everything you can able to detect. So using these minor violation of your road rules as well, the ethics, physiological approach. So these are all the physiological approach. So these thing I'm not going to focus on. My initial thing is that the system has three different layers of alert responses. Stage one, preliminary warning. So it includes some audio signals like beep sound when a drowsiness is detected in driver with respect to some face expressions or blinking, some kind of an violation of a normal gesture of the head or yawning status and eyeball movements and facial expressions. So this will be notified by blinking red visual alert to the driver. Driver himself knows that audio signal is raised, so he can alert. The critical alert if that sound is not audible to him and he felt deep sleep into it, and he can able to, if that drowsiness is little higher level than the preliminary warning, so we can go for a louder warning signals and some SMS alert signals with sound, so that he can able to identify that SMS is received and some louder warning is raised in order to make awareness about his state of uh, drowsiness. Advanced any kind of an levels, the system can connect to the vehicle controls to activate features like seat vibrations or some controlled deacceleration. So when I had used two data sets in order to validate my model, I had used not only this CNN model, because the CNN model in existing everybody has used. So in order to identify some innovation technique, I had used a methodology in software. It is in a customized source code, which is especially used for finding this detection in driver's face fatigue and identification. So my first validation is basically on all my from my data as well the project, the effort score is 85 percentage, precision is 89 percentage, and recall is 84 percentage. It is actually my total accuracy is with respect to facial landmark 92 percentage, and my quality of the localization is 85 percentage, and with respect to eye aspect ratio in real time analysis, I had used these two data sets for the same parametrics, so that I can able to identify why these two data sets are used in the sense here. One data set is not sufficient to identify. Only from the first data set, I can use the drowsiness. Second data set is used to identify yawning status from the face recognition. So I had used two data sets for validating my project. So these are the results obtained from the project or from the proposed system, where high aspect ratio, this blue dotted line indicates high aspect ratio, and this red dotted line indicates yawning score, and this blue dot line indicates EAR threshold, drowsiness detection threshold. Threshold in the sense minimum value is set for the drowsiness. Anybody can close eyes, can blink their eyes and widen their eyes whenever it is required. But when you are driving, some amount of closing eyes is negligible. So when it close to
Yes,
eyes, if
ma'am,
you close
please
the eyes, it will
conclude your
identify.
PPT.
Pardon?
Yeah, can you conclude your PPT?
Sure, sir. So this is going to be not only this CNN model is as such it is applied. I'm going to make use of that. I'm going to use a customized code, Python code, which is used for obtaining my results. And this is obviously state-of-art algorithm as per the accuracy and all the objectives are accomplished here. The future enhancement is only behavioral aspects I had used for validating my project. You can make use of heart rate monitors and you can view in-depth other aspects using EEG signals and other things you can detect and you can get some accuracy, more accuracy from the model. Thank you so much.
Good work, Dr. Sujata. But actually, I would like to know how can you say that your model is superior to the existing one? There are a lot of study which is already going on drowsiness detection and all. So
Yes,
your
sir.
accuracy, you claimed it to be 92%, right?
I had I had conducted a literacy survey in such a way that existing models also uses CNN model. That is why I stated during my proposed algorithm, I do find that CNN model is the existing one. I want to make it as some innovation in my contribution in my project. So I had used a customized concept where to improve my it's
So
the optimization technique in data set. No. And one more thing is that many existing also used close to my accuracy, but it is not drastically improved my accuracy when the existing system is concerned. As Sir said, many existing algorithms are used using CNN itself for drowsiness detection, but still I found that some improvement, maybe 0.5 sometimes. One paper, I had identified that when I conduct literature survey, I do found that 0.5 is the
okay,
maximum
uh,
accuracy I can get from others existing.
okay. So Dr. Sujata, please add a slide. There is a little improvement comparing the existing one, and not only CNN, there are other techniques also used, maybe not that much prevalent. So, and maybe the improvement given by you is very minor.
Yes.
CNN, what
Existing
is
and
existing one and not existing one, others, and
mm.
your one, so that you can show
But
your contribution.
as far this slide is concerned, I haven't prepared that comparative chart for existing and my proposed research actually. So when I conducted literacy survey, I found that at least maximum 0.5, at least difference I wanted to show. So that was obtained. So I started preparing a manuscript for this. So that's what, but I didn't prepare any analysis, existing and proposed analysis. I haven't
So
done so.
do that also. So so whenever you are going to submit final draft,
Yes.
try to put that in
Sure,
your
sir.
research paper.
Yes. Yes, sir.
Uh, Dr. Dilip, would you like to ask anything?
No question, sir. I just want to ask about the data set. What was the data set?
Data set, sir.
Yes.
These are all the two data sets which is displaying now.
No, what was the size of data set?
Excuse me.
Size of the data set.
Size of the data set,
Yeah.
1024 rows and 111 columns, sir.
Okay. Right. Thank you.
Thank you, sir.
So is next, I think Sataditya is next. Sataditya Jana.
Yes, sir.
Sataditya, are you
Sir,
there?
yes, sir. Am I audible?
Yes, you are. You may please start.
Okay, sir. Just a minute. Let me just adjust. Can you see my screen, sir?
Yes, we can.
Just a minute.
Yes.
One minute, sir. Let me fix the camera on. Okay, sir. So I'm starting now. So, ladies and gentlemen, welcome to a new era of Atherosclerosis. So I'll be presenting ICML 168 early atherosclerosis prediction integrating cardiovascular biomarkers and human health, a probabilistic AI-driven model. But before diving deep into the paper, I would like to introduce my team first. So I'm Shatayat Triana from BTech Biotechnology SLP, Sulin University, and I'll be a presenter. And I have contributed as the first author of this paper in software analysis and writing the original draft. I would like to introduce Ms. Atherosclerosis next from BTech Biotechnology Research, Sulin University, as the second first author of this paper, who has contributed in the result analysis and writing the original draft. I would like to introduce Ms. Aditi Singh next from BTech Biotechnology Research, Sulin University, as a co-author of the paper, who has contributed in the result analysis section. Next, I would like to introduce our corresponding author, Dr. Azhar Khan from Sulin University, Professor of Biotechnology, without whom the paper was
Yes,
incomplete.
there is no need to introduce, just start your topic
Yes, sir.
because we are already running late.
So let's go to the literature review first. So according to WHO and IHME, there are 30 million plus cases of atherosclerosis per year, which are the leading cause of ischemic heart disease and strokes. And this is completely...
Sataditya, can you be a little bit louder?
Okay, sir. Can you hear me clearly?
Yes, you are now.
Okay. So atherosclerosis, according to WHO and IHME, has 30 million plus cases per year and is a leading cause of ischemic heart disease and strokes. And also, it is completely interlinked to the modern lifestyle because of the dietary habits and low physical activity. So mostly the urban lifestyle. So next, I would like to point out some critical gaps from the atherosclerosis nature, which are the most cause of diagnostic failures. Because of the silent progression, it cannot be detected in the early stage. Right now, in the diagnostic system, also undetected genetic tendency is a major cause, and public ignorance, because of the asymptomatic nature, makes it completely difficult to detect. So there are 4 types of atherosclerosis diagnostic right now. That is current imaging techniques, biomarker screening, AIML application, and ECGs. So they have each of their flaws. So first of all, imaging techniques, they are mostly suggested by doctors and does not require routine checkups. But in the asymptomatic stages of atherosclerosis, like the early stage, patients do not go to doctors for this, so they do not avail imaging techniques. Thus, early stage atherosclerosis evades the most imaging diagnostic techniques. Also, some resolution problem is there, so the imaging techniques cannot detect early stage atherosclerosis in the first stage, like when it is in the pre-stage or something like that. And biomarkers, right now, biomarker screening standalone cannot detect atherosclerosis because they only provide a qualitative analysis than a quantitative one. Next, I would like to introduce the AIML applications that they are actually limited in training data sets and lack of clinical validation. Also, they cannot they generate false positive and negative results because of the data bias system. Also, the ECGs, they can detect the abnormalities based on a significant atherosclerosis progression, but not like in the early stages. So why focus on the early stage detection? Because according to WHO, it provides a improved survival rate and better chance of complete curation. So patients can be better after the like pharmaceutical treatments and all that after this treatment. So is it possible? Okay, we have made it possible with a quantitative like modeling. So I'll introduce the quantitative modeling next. So here we have actually used data analysis, probabilistic modeling, and also biomarker screening like with that. And we have provided the insights of atherosclerosis tendency in early stages with percentage scaling and all. So let me introduce the model. So firstly, we have taken 9 biomarkers here. So the biomarkers are physical biomarkers are BMI, blood cholesterol, blood glucose, and blood pressure. And the lifestyle influences are dietary habits, physical activity level, stress level, and tobacco use and alcohol consumption. So what we have done, we have created a mathematical model. In first, we take a factor, then scale it based on the like percentage scaling. We have used that method. Then we have compared its risk to the atherosclerosis threshold, and then all these factors with the threshold risk are correlated by a mathematical model. So with that, we have obtained the tendency of atherosclerosis in a quantitative way. So this is the whole derivation. I won't explain it. I would just, you can take a look at it and you will understand. So this is the whole derivation of the model. And this is the whole formula that we have derived. So on this formula, the mathematical model, the whole software is working on. Now to test our results, so to test the model, we have like obtained the data set and human age prediction synthetic data set from Kaggle. Just don't be confused with the name because it contained all the disease risk and everything there. So it was actually 3000 dataset, but due to the restrictions, we only obtained 1700 dataset because there are some data missing or some data incorrect. So we have done the data analysis with OpenAI ChatGPT data analysis tool. So after that, this was the software. So firstly, it is taking like the personalized data. Then we are in the input layer. We are in feeding the data. Then there are five, six more layers, which is like screening the risk from there. Like based on the mathematical derivation I have provided you, it partly like gets all the data and screens it, and then finally like and say at that age of the person. So I'll move to the next. So in randomized trial, we have obtained 96.41% accuracy on this model. And in genetic screening, we have obtained 97.1% accuracy, which is really, really higher than the existing ones. So this was the nature of the dataset that we have obtained, and this was the result dataset. So in conclusion, I would like to mention that this quantitative modeling is the first type of its first of its kind. Like no one have introduced a modeling in health diagnosis like which can do quantitatively tendency prediction and all. But as I said, this was a synthetic data set, so it needs real data validation. So we are open to all collaborations and all for the phase 2. And this model has in synthetic data set has performed well. So that is the conclusion of the model. So I would like to sincerely thank the ICML committee for arranging this, and I would like to thank Sprinter and Microsoft, without whom this wasn't possible. So thank you. That's my presentation.
So, Skaditya, it was a very good work you have done, but still the same problem I find out.
Yes, sir.
You haven't shown the comparison of the output or the accuracy
Okay,
of
sir.
your model with the existing one. You know,
So,
whenever,
sir, first of
whenever,
all,
Mhm.
the quantitative model has not existed yet. All of the models in atherosclerosis provide qualitative analysis, so we cannot like do a comparison between that. But where I have mentioned the accuracy of the model, so it's based on the clinical data. So doctors have provided the data. So based on that, that was actually screened data, and we have made the run the model, and we find 96% cases matching.
See, in the last slide you have said you talked about certain type of synthetic data. Go
Yes, sir.
back to the last slide.
This size, sir.
So here you have claimed that you have gone for the synthetic data also, right?
Yes, sir.
So on one side, you are saying that the data is validated by the doctor, and on other
Okay, sir.
side,
So
we are
the
going
data,
for
the
we
data
are
set.
claiming.
So, sir, data set was synthetic because of like that because of some of the data was synthetic, but the doctors have screened the data and detected that these patient data were like matching, and they were like because actually
So
synthetic age prediction data set. The data set was real, but the age prediction was synthetic. But this is not the age prediction model. The data set was completely real. So like with that, because they enlisted all the numbers and all approvals. So that's it.
that is what is the problem with the synthetic data in medical field. If it is going to be something else like finance or like that, there I have seen databases which are approved, which are considered good enough. As far as medical is concerned, one should avoid synthetic data.
Yes, sir. But
So
right now, that model we have used is concerning. So we are thinking about that in phase 2 actually.
okay, and go to the final formula.
That's the final formula of the model, sir.
So can you tell me what are these WD W
like for diet, there is a weighted risk. For like physical activity, there is a weighted risk. So they are also derived from the research papers. We have taken them from research papers. How much, like for let's say for physical activity level, with a low physical activity level, there is a 60% chance of atherosclerosis. So the weighted risk would be 60 in 100% case. So we can fractionize that for physical activity level.
Okay. Thank you, Sataditya. Dr. Dilip, if you have anything to ask.
Yes, sir. No problem. No question from my side.
Okay, thank you, sir.
So let's take the next candidate, Muskan Rana, paper number 192. Muskan, are you there? Hello? I think Muskan.
Muskan, your voice is not reaching to us. Hello, Muskan. Are you there?
Yes, now you are.
I'm just sharing the screen. One. Good afternoon, everyone. My name is Muskan, and I'll be presenting our research on enhancing the cybersecurity physical social system based on deep learning, driven pattern recognition. And this research was done with along with me with my co-colleague, that is Kanika Sharma and Samiksha Sharma. So starting with the first slide, that is an overview of cyber physical social systems. Cyber CPSs integrate physical components, digital infrastructure, and social in smart cities, healthcare, and transportation systems. Their interconnected nature introduces security challenges beyond traditional cybersecurity as threats span across dynamism make real-time anomaly detection and threat mitigation difficult with the conventional method. To address these challenges, the study presents a deep learning-based security framework named ACGSEL, Alert Collection Genuine Service Evaluation Logic, leveraging CNN, RNN, and adaptive learning. The framework automates threat detection from diverse data sources and reduce false positive using a crowd-powered validation mechanism. ACGSEL integrates seamlessly into existing CPSS infrastructure and shows improved accuracy and responsiveness across public data sets, offering a scalable and practical solution here is automation and accuracy and real-time threat detection. So automation and accuracy means deep learning enables automated feature selection and higher accuracy in detecting the anomaly, more effective than the conventional method in handling the high dimension data. And the real-time threat detection, that is, deep learning models facilitate rapid identification and mitigation of potential security threats, essential for application with the critical implication, for example, the health. Slide. And based on this previous work that has already been done, that is first was rule-based or the statistical method. And here the advantage was it was simple for the implementation part, but there were certain limitations that it was not easily adaptable. So that is one of the disadvantage on this particular first paper that we have used here. Traditional machine learning is another paper where we have used a technique SVM decision trees, and it also has certain advantage and disadvantage. And the disadvantage was that it was very limited to the threads. Supervised machine learning was another paper that was based on multiple supervised algorithm. And here the advantage was that it was good at detecting the daily, like 0-day threats, but the disadvantage was it requires a very large labeled data set. Next was based on unsupervised machine learning, where the researcher has used clustering and autoencoder techniques. And the advantage was that we need not to take the labeled data and it can detect the attacks automatically or the genuine attacks. And the the results were getting us. Fifth technique was based on deep learning. And here the technique that was used here was CNN. And again, there was disadvantage and advantage of it. So the disadvantage was based on lack of context from the physical and social data. So the data was not clearly available from the social media, or the physical data was not available easily. So these were the literature survey. Many other literature surveys we have included, but in the PPT we have done, like, the comparison was done between rule-based traditional and the supervised machine learning model. Next was, so this is the description of our base paper. So this paper proposes a deep learning enabled architecture to secure and optimize CPSs in smart city environments. The author explored how multimodal data from IoT sensors, social media, and physical system can be fused and analyzed using deep neural network to support the architecture for CPSs with data sensing, processing, and application layer. And we applied here deep learning, CNN, and LSTM performance in traffic monitoring, anomaly detection, and citizen behavior. And we have emphasized on the importance of the context-aware, adaptive, and real-time data fusion. So this is the proposed methodology, how we have designed a framework. So we have collected a CPSS data from website, that is Kaggle, and then the processing and the cleaning was done, where we have two algorithms, LSTM for temporal data and CNN for spatial data. Then the integration and the fusion was done. So we have combined both the data, and integration was applied here, and then anomaly detection was done here in the next step. After this, model has been trained, and we have the real-time threat detection, that is the threat. And if there is any threat, the alert has been generated or alert has been triggered. So these are the steps where the methodology we have used here, the data processing and the cleaning, and we have included how data processing is being done. So the data cleaning is basically eliminate the noises and inconsistent data points. Whatever relevant data is required, that is included in the data cleaning, and rest the inconsistent or any unwanted data features are being removed in the part of data cleaning. Then we have second step, that is anomaly detection and real-time classification, where we have fused data using the deep learning model, that is LSTM and CNN. So LSTM is used for temporal patterns, that is based on sensor time series data, whereas CNN is used for spatial features and usually working on the network traffic data. So we have combined these models to get the integration of this particular model. Then this was the result, sir, that we have compared our model with the three of the models or technique that was used previously. First was rule-based or the traditional AI. Second was SVM, and third was based on CNN. And this was proposed model is our model, which we have worked on, and we were getting the result in the difference was in accuracy, false positive rate, response time, and adaptability. So if you see here, we have a percentage. Whereas our proposed model gave the accuracy of 95.2%. Similarly, for the false positive rate, we have 15.2%, 10.1%, and 7.8% in the previous techniques that was used, whereas the proposed model here, it was giving us 4.3. So there is a difference in the false positive rate. Similarly, in the response time also, we have the least response time, that is 180 milliseconds, and the adaptability is also like continuous. We can use it anywhere, and it is generally used in the smart cities, and most of the time it is used in the smart cities. We can use it. So this was the result that was generated from the application that is from the language that is Python, and we have worked on the Python machine learning models only. So analysis of threat detection on different CPSS layers. So these are the like on physical layer, how it is giving us the result, on cyber layer, how it is giving us the result, and on by combining all these layers, we are getting the accuracy and the false positive rate of 95.2% and the 4.3%. That's the outcome that we got. On concluding our research has validated the viability of using a deep learning-based pattern recognition approach for security enhancement in CPSS by using multiple layer framework comprising LSTM, CPSS, CNN, and MLPs. The real-time threat recognition can be leveraged. Also, the algorithm security in future covering various threats. Results obtained from the model are better in terms of false positive rate, response time, and accuracy as compared to the other traditional rule-based models. The accuracy achieved is 95.2%.
Okay, sufficient, Muskan, sufficient. Very good work done by you. The thing is, I would like to know about the data sets and the parameters you worked upon. And the second thing, I would like to know about the tools you used or we can use to reproduce the result on the same data set. You said Python. So which library exactly in the Python?
The PyTorch and TensorFlow we have used for evaluating it. And data set that we have used it was from the Kaggle website. So we have downloaded the data set from the Kaggle.
See, Kaggle is a very big website and has got thousands and thousands of data set. Which specific data set have you worked upon?
So we have used the data set from the smart city, so like for the
Smart city.
Yes, and the
every data set has got certain code, certain name. So
actually, I understood your point, sir. Actually, this is
the thing is, whenever you propose some model, you don't know about the data, right? So we also go to, let's say, Kaggle, and somebody else will go. So try to put specifications of the data set so one can reach to the same data set. Or what you can do is, if you have Excel worksheet or CSV file of that data set, attach this as an additional file with your paper, right?
Okay, sir. I'll take care of this next time, sir, for sure.
But actually include that whatever data set you worked upon, include it in auxiliary files or additional files, right?
Okay.
And I would like to suggest the other researchers also, like the Muskan has given a comparison table. So try to is very good used by Muskan. And yes, there is a suggestion for Muskan also. There are a lot of contents in this text content in the slides, right? Try to make it in a bullet points. No, right? So less time will be there in reading. And anyway, it was a very good paper you presented.
Muskan, which method you have used for the feature fusion?
So, I'm sorry, sir, your voice was breaking.
Which method you have used for the feature fusion?
For the?
You have fused the temporal data with the spatial data. So which method you have used for that?
It was the LSTM and CNN that we have used for the flow chart, as we see here, na?
So how you fused those features?
based on accuracy and the false positive rates, we have used this, and the response time was the features that we have used. And we used two algorithms, that was LSTM and CNN.
I'm asking about the fusion of features.
It was the physical and cyber and social fusion of the features that we have used. It was like physical, social, and the cyber physical layer were combined into one single model, that was multi-model, and we integrated all these models together.
Okay, I think we are now running short of time. So I request all the authors to stick to
Yes.
their timing
So
of 8 minutes. Next author is Sayan Pal. Sayan, you stick to 8 minutes only. So you have 8 minutes to finish your PPT. Sayan, you are not audible. Sayan, you are not audible. मेरी आवाज आ रही?
Hello. Sayan, you are not audible. Sayan, you are not audible. Hello. Sayan, you are not audible.
Yes, he is not audible. I think he is not able to listen our voice.
So, no, I think he is changing his audio system or like that. Hello, Sayan, are you audible? Hello, Sayan. Hello.
Sir, in the meantime, we can take the next presentation.
Yeah, yes, we should take the
Yes,
next.
presentation.
yes. So next is
Dr. Sonakshi Mehra.
yes, Dr. Sonakshi Mehra. Is she there? I think she has not joined. So next is 246, paper ID 246, Srinivas Seshadri. 246. He is there, I think. 246, Lavanya. Yes, paper ID 246. 246 है. I think he is not there. So 329, Kedareshwar.
Yes,
Kedareshwar.
Kedareshwar is there.
Yes, sir. Let me share my screen, sir.
Okay.
Sir, excuse me. Can you hear me, sir?
Yes,
Yes, you
we
are
can hear
audible.
you.
Yes. Srinivas Seshadri. Instead of Srinivas Seshadri, due to health issues, I'm presenting, sir.
Okay.
So-
what is your name?
Lavanya.
Okay.
Okay, sir. We allow.
Hello.
Yes, Lavanya, you are allowed.
One of the co-authors.
Yes, yes, sir.
Okay, Lavanya, you can start now. Kedareshwar, wait for a while.
Sure, sir. Sure, sir.
Lavanya, you have 5 minutes, right?
Okay, sir. Can you visible, sir?
No, your screen is not visible, and actually your whole of your screen is visible. So it's being mirrored infinitely. Okay, now it's okay.
आप लोगों को दिख रही है?
Mhm. Hello, Lavanya.
Yeah, sir, I'm available.
Okay.
Just a minute, sir.
Yes, now it's okay. Just
Now
maximize the screen and start.
Good afternoon, sir. Myself, Lavanya. I'm presenting the topic of pre-trained deep learning models are sufficient for X-ray image analysis.
Lavanya, please switch on your camera. Hello, Lavanya. Yes. Maximize your screen and then you can start.
Yes, sir. So today we are in a world of AI in medical imaging, and here it goes with our main research is about chest X-rays. So what we had done here is so far with the deep learning and pre-trained models and with the processing of steps, we had a research in chest X-ray images alone. And the main process is for fine-tuning the pre-trained model is enough for complex X-ray analysis is the aim of our study. So for this, we had a critical role of image processing in order to improve the performance of the models. So here the conceptual definition goes with the three topics. One is of pre-trained models, another one is data augmentation. The data augmentation model is enhanced with the model of Clatchy, which is contrast limited adaptive histogram equivalent. Have pre-trained model in action of AlexNet, VGGNet, and DarkNet. So here, before deploying all these models in our data set, we had three steps of pre-processing.
Lavanya, you move your PPT also.
Image resizing, normalization, data augmentation. X-ray dataset which has 14 common chronic diseases. So here the major challenge is class imbalance. In order to achieve this, we had identified three research gaps with the problem statement of pre-trained deep learning models are providing reliable, accurate analysis of chest X-ray images. So with this, I'm getting into the research. One is of enhancing diagnostic accuracy, another one is of improving patient outcomes, another one is the wide usage of this model in and broader applications. The problem statement is pre-trained models are not sufficient for analyzing X-ray images due to the problem of ambiguity, class imbalance, and interpretability. So, in order to achieve this problem statement, we had a research questions. Either this it is more sufficient, or we need pre-processing and augmentation is though.
Lavanya,
So,
are you moving your slides?
yes, sir.
But you are on the very first slide only.
No, I had moved, sir.
Yes,
Now,
now it is
okay.
visible.
Okay.
Okay, this is so in order to claim the research question, we had four different objectives. One is to evaluate the performance of AlexNet, VGG, and DarkNet. Objective two was usage of that is deployment of pre-processing pipeline, and objective three is systematically comparing the performance metrics of models with the proposed pre-processing steps. And the finalized one is to analyze the influence of regularization like dropout and L1 on model performance. So this is the overall pipeline of our approach. So here our approach goes with the data set of NIH and the pre-processing. and the models deployed and the technical experimental setup we had deployed for in order to implement the process, and final stages of evaluation metrics. And the oils with the pre-processing steps. So why in case of AlexNet, we had reached the accuracy of 0.92. In case of precision is 0.90, recall 0.93, and F1 score is 0.91. So finally, we are concluding that pre-processing is not just a preliminary setup; it is a crucial for our success, because pre-trained models are not only sufficient here. Whenever we are getting only with the pre-trained models, we need pre-processing steps too. That's our motive. These are the references for the research we went. Thank you, sir.
Okay, Lavanya, can you elaborate about the data set and the tools you have used?
Actually, for the data set, we took National Institute of Healthcare data sets, chest X-ray. It's about having 14 different respiratory diseases. One thing, and the tools we had used, we just with this is a data set we had directly downloaded it from the website of NIH. Further, for experimental session, we deployed only the thing is about AlexNet, VGG, and Darknet. We include the model of CNN for this, and our suggestion is instead of directly employing of pre-trained models, we need the pre-processing step.
Okay, over to Dr. Dilip, if you want to ask anything.
No questions, sir.
Thank you,
So now we take the Kedareshwar. Kedareshwar, now
Yes, sir.
you can start.
Yes, sir. Sir, I hope my presentation is visible.
Yeah, it's visible.
Okay, sir. Thank you, sir. Good afternoon, everyone. Respected session chairs, fellow researchers, and participants of ICML Algo 2025. My name is Kedar Eshwan Naidu, and under the guidance of Mr. Aman Kumar and Dr. Samish Sharma, sir, I am honored to present the work Enhancement of Endoscopic Images and Videos using advanced deep learning and traditional image enhancement techniques. Endoscopic imaging is widely used for diagnosing gastrointestinal diseases, but these images often suffer from poor poor illumination or contrast, noise, blur, and which can make diagnosis challenging for clinicians. Traditional methods like histogram equalization and adaptive filtering help, but they either oversmooth the images or lose fine details. Our motivation is to design a deep learning based enhancement framework that improves the clarity, preserves critical structure, and supports more reliable medical diagnosis. And literature review. In recent years, there are state-of-the-art models like CNN, ResNet, DenseNet, and GANs and transfer learning have shown success in medical balance, both the resolution improvement and structural preservation. This gap led us to design a hybrid pipeline that brings together the strengths of super resolution convolutional neural network and a dual input unit while still allowing post processing flexibility. And a proposed enhancement pipeline consists of 5 stages from pre processing, super resolution, CNN, dual input, and post processing. We have used 5 publicly available endoscopic datasets, and this is the matrices of the dataset. They cover like variety of conditions such as polyps, ulcers, inflammation, and imaging challenges. They also have images like motion blurred and poor illumination. The diversity makes our result more clinically reliable. And the first step, first deep learning stage in enhancement pipeline, that is SRCNN. Why we choose SRCNN is because it is lightweight and it is very fast to train, and it is specifically built for this purpose. And with just 3 convolutional layers, it's proven effective in generating high resolution detail for medical images. And this output of this SRCNN will serve as an input for dual input unit. And this SRCNN will restore fine details lost due to any poor imaging conditions previously. And the unit model, here we have configured the unit to go a step enhanced images as well. It takes as an input, and this way it combines contextual integrity from the original and also the fine detail from SRCNN. And so yeah, these are the configurations of our model. We have trained it for 100 epochs with a batch size of 16 and used Adam as the optimizer with a learning rate of 0.001. And this loss function is very essential and crucial for our model, because this loss function, this preserves like clinical features. We designed this custom loss function. The edge loss ensures that if there are any tiny anatomical structures such as muscle folds, that will remain sharp. Here W1, W2 and W3 remains the weight of the model, and L1 is being the L1 loss, which shows a pixel level similarity for PSNR and SSIM values, and MSC and mean square errors, and edge being the boundary preservation in the formula. So if we discuss the results, it is near 38.77 PSNR and 0.98 in the SSIM. And for the dual input unit, it is 31.18 PSNR and 0.89 SSIM. And for final post-processing, after final post-processing, it is 23.97 PSNR and 0.77 SSIM. It is dropped, but we have taken into consideration that PSNR and SSIM compare like pixel fidelity with the ground truth. But post-processing, like our post-processing modifiers brightness and contrast, so matrices dropped, but visually clinicians can see better clarity. So these are the results we have obtained. Like if you see, this is the original image and this is a final enhanced image by our modular enhancement processing pipeline, and even the edges are clearly captured in this. And while coming to inference time, the parameters for all combined, it is nearly just 4 million parameters for all our pipeline, and the memory is around 650 MB. Like that's how much our pipeline is, and it's very lightweight and it can be used for real. And like by this we have achieved like enhanced resolution with while preserving the structural details, and also we have preserved the edges through custom loss function, and we have at least come across this motion blur and lighting issues, and we have tried to improve diagnostic accuracy for various endoscopic scenarios. And the future scope. So in future, we plan to generalize further by training on more diverse or multi-institutional datasets, and to give domain adaptation for different endoscopic manufacturers and self-supervised learning from unlabeled images. And we would like to work towards real-time clinical development, integrating the model into endoscopy systems, and also to add AI-assisted diagnosis features like polyp detection and lesion segmentation, so it can automatically detect any abnormalities, and real-time decision support for clinicians, and to use different multi-model learning, like different like patients previous any previous patients documentations, and other images and other scanning reports. So this data integration from multiple sources will improve the diagnosis even further, and the clinical assessment will be more reliable. To conclude, our SRCNN plus dual input unit hybrid pipeline provides a balanced approach. It will enhance resolution and structure while preserving critical diagnostic features. We believe that this work marks an important step towards AI-assisted endoscopy that is reliable, interpretable, and will be clinically useful. Thank you for listening. I'll now be happy to take any questions.
Kedareshwar, can you tell me before you introduce this your algorithm,
Yes, sir.
your model, which one was there for the purpose of comparison? Like you claim that this one is better one, but
Sir,
is there any existing model to compare with?
Actually, sir, we have compared it with existing state-of-the-art models like GANs and transformers. And here you can see the fifth paper, Enhancing Endoscopic Surgical Imaging AI-based Smoke Removal and Image Enhancement. We have compared this model and the deep learning, here, bright VI luminosity enhancement in underexposed endoscopic images for luminosity and contrast and perspectual similarity. But our paper is not better than these papers. Actually, our model performed a little low on the PSNR and the other matrices. But our model have got the, like, this is a trade-off we have given for the visual, like, perceptions for clinicians for better interpretability.
Particular parameter, let's say you're working on the intensity. So you would have compared it with some existing model which are working on intensity. So
Yes,
there you can show some improvement. Anyway, you have made a good effort, and in future scope you may improve this model by other ways, by this mean or that mean,
Okay,
with the integrity.
Okay, sir. Thank you, sir. Thank you.
Better intensity.
Okay, sir. Thank you.
So over to Dr. Dilip if you want to ask anything.
Yes, Kedareshwar, you have not used the detailed methodology diagram in your PPT. Why? Just the CNN
Sorry, sir.
diagram.
Like the pages.
Yes, what were the pre-processing techniques and how you handle the noisy images?
Some of the chats.
आवाज नहीं आ रही. Hello.
Hello, sir.
Are you able to hear? I was just asking about the detailed methodological diagram.
Sir, like the slides were limited to slides 10, sir. And,
but I think that is the most important diagram for your research paper.
Yes, sir.
That
Yes,
you
sir.
have not included. So how you handle the noisy images as you have used the diverse data sets?
Yes, sir. Like there is a difference in the image sizes and there is some noisy images too. And we have used all these images for like training our model to better generalize over the real-time endoscopic images. So first we have resized the images to 299 by 299 pixels, and we have used standard normalization techniques. And like we have ensured that it will be consistent across all the input data. Yes, sir. And we have used Clash and other processing steps to process the images and make it standard, sir.
Okay. Right.
Yes,
Thank you.
Thank you, sir.
So now there are two which are remaining. Sayan Pal and Dr. Sunakshi Mehra.
Yes, I think Dr. Sunakshi Mehra is not available today, so she will deliver her presentation tomorrow. So we have only one paper now.
Sayan Pal.
Yes.
Yes, sir. Sir, am I audible?
Yes, you are.
Okay. Let me share the screen. Is my screen visible?
Yes, it is visible.
Okay. Sir, my name is Shayanpal and I am from the Department of Computer Science, the University of Burdwan, West Bengal. And our paper ID is 206 and it is our privilege to developing a machine learning based expert system to forecast heart illness. So these are our contents like introduction, theoretical background and other things. first we will see introduction. As we all know that the CVD or cardiovascular disease is a global cause of mortality. According to the World Health Organization, around 17.1 million deaths annually occur for the reason of cardiovascular disease. Right. And secondly, as we know that there are already some available methods which are used for diagnosis like ECG, CT scan, etc. But both of them are very much costly. And in India, there are some places where ECG, CT scan, and this type of things are not available, easily available. So early and accurate detection is crucial to reduce the socioeconomic burden to heart disease. And why machine learning? Machine learning offers a data-driven, cost-effective alternative for prognosis and risk prediction, obviously. And our study type of bagging algorithms for prediction, and we use the data balancing technique, that is the k-means mode for data balancing, and we use 4 feature selection methods. These are the chi-square method, correlation matrix, sequential forward feature selection, and sequential backward feature selection. And not only that, our model through these steps, our model gets an accuracy of 99.83%. And we also mentioned the dataset here, that is, we collected our dataset from the website that is Kaggle. So here are some conceptual definitions like what is heart disease. As we know that the range of condition affecting the yes sir.
Sayan, directly come to the literature review part.
Okay. So these are some literature review papers which we generally use for our study, and here it is the table. Here, as we can see that after performing a detailed literature review, we are able to find out some key findings. These are, if we see the first row, then we can see that the XRT classified in for the first case, the XRT classified got the accuracy of 97.223%, and there are other authors along with their research work, and as we can see that all of them can get the accuracy below 97% or below 98%. And not only that, we also able to find out some gaps here. Like in case of the first section, first row, we can see that the authors did not handle data imbalance or multiple features. The fourth one, they use a very small UCI dataset, and for the case of fifth one, they do not use any kind of cross-validation technique or feature selection method. So these are the premises of research gap which we are able to find out.
Sayan, please switch on your camera.
Okay, sir. Sir, is it right? Okay, sir.
Now it is
We are
turned
not
on.
able to see.
Earlier it was on.
Initially, it was
Yes,
on.
yes, it is now on.
Okay.
We are able to see him, sir.
Okay. Continue, Sayan. Maybe some problem is here.
Yeah, I think so.
Sir, so these are the premises, like prior models often ignore data imbalance and robust validation, and lack of reproducibility across methods or datasets, and no study combined k-means mode, 4 feature selection methods at the same time, and 5 classifiers. All these things why to study this thing. Like as I have already told you that the cardiovascular disease is the leading cause of death, and some traditional diagnostic techniques like ECG, CT scan, these are very much costly and not accessible in the different type of regions.
It has been already covered, Sayan. Directly come to your model, your solution.
Yes, sir. But before going to our methodology, we just highlight some research questions here. Like there are two research questions. Like how can ensemble learning improve prediction accuracy in heart disease detection? And the second research question is, what is the effect of balancing and feature selection on model performance? Here, if we see the proposition column, then we can see that the ensemble classifier like random forest decision tree, they significantly outperforms the individual models for heart disease prediction. Right, and the second for the answer answer of the second question, the k-means mode combines with feature selection method significantly enhances the accuracy, precision, and recall for ML classifiers. So this is the methodology where we use the dataset which is collected from the Kaggle. The name of the dataset is Heart Disease Health Indicator, which has around 1 lakh of rows. And here we initially we perform some data pre-processing phases like data in cleaning, like null value removal and other things. And then we perform data encoding phase to feed our dataset into the models. And we also normalize our dataset. And after that, we perform data balancing technique. Here we use the k-means mode. After that, we use 4 feature selection methods like chi-square, correlation matrix, and sequential forward and sequential backward feature selection. After that, we set our model to, we apply 5 models into this approach or in our model, in our workflow. That is the decision tree classifier, random forest, LDA, XRT classifier, and the Atherosclerosis. And not only that, we also apply validation techniques like 10-fold CV for matrix evaluation, like accuracy for calculating accuracy. Collected the dataset initially, then we perform some data pre-processing phases, and after that we check whether the dataset is balanced or not. Or in our case, our dataset is not balanced. That is why we applied the k-means mode technique for data balancing. After that, we again check another thing, that is if we need any kind of feature selection method or not. Yes, obviously, in our case we use 4 type of feature selection. That is the chi-square method, correlation, sequential forward, and sequential backward. After performing the feature selection method and data balancing technique, we directly go to the evaluation section, where we apply 5 classifiers, 5 ML models. Like these are the Atherosclerosis, static classifier, decision tree classifier, random forest, and LDA, that is linear discriminant analysis. And we just after applying these models into our methodology, and then we calculate the evaluation matrices like accuracy, precision, recall, and F1 score, and we collected all the outputs. So again, this is the all the steps that I have already told you. And here are the outputs. Like the random forest and decision tree classifier achieved the highest accuracy of 99.83%. And we got this accuracy after using the 10-fold CV or 10-fold cross validation. Not only that, our model uses the k-means mode, which successfully resolves class imbalance, which is also, as I have told, not only resolve the class imbalance, but also it improves the model generalizability. The chi-square method and correlation-based feature selection contributes significantly to boosting our model accuracy, obviously, and we perform some evaluation matrices that accuracy, precision, and recall across 5 classifiers. And according to the best of our knowledge, our model outperformed all the previous studies, confirming its robustness and clinical reliability. So this is the output table where I just give the visualization. As here we can see that the decision tree classifier and random forest got the highest accuracy, that is 99.83%. Not only that, if we see the total output table, then we can find out that this is very balanced. All the outputs are very much balanced. Like that in case of decision tree, all the values are around like 89 to 99% between them, and diagram section, we do not use any kind of splitting technique. We directly throw our model to the 10-fold CV. So in future, we will obviously train our model with the universal splitting ratios like 90-10, 80-20, and 70-30 to simulate real-world deployment challenges. Not only that, our proposed model is a predefined model, or which is a publicly available model. As I have told you, that is I collected it from Kaggle, and in future we will obviously use the dataset of UCI Cleveland Heart Disease dataset for real clinical data. And also we will apply the explainable AI techniques like SHAP, LIME, etc. So to explain our model, or to open up the black box, to explain how our model actually works behind the scene, right? So for this we will obviously use in future explainable AI, and evaluate the model performance using the time-based demographic based stratifications like age, gender, geography, etc. And not only that, we will also deploy a expert system in future we are planning to develop a UI for our model, which will easily interact with the users. Not only users, and the clinicians also use it for their different type of purposes. So this is the future scope, and these are the references which we use for our study. That's all from me. Thank you, sir.
Sayan,
Yes.
can you tell me how did you produce the results?
Sir, as I have told you into the pre-processing, into the methodology section, let me go to that section. Yes. At first, I take the dataset from the Kaggle, right, and then I perform different type of data pre-processing phases, as I have already told you. Then I perform the data encoding.
No, my intention is to ask you about the tools. How did you produce?
Okay,
Which
okay.
tool?
I
Which tool?
use Python as my language, right, and our ideally is a Jupyter notebook.
And which library did you use?
We use the library like for visualization we use the matplotlib and scikit-learn, and for library, etc. These are the libraries which I have used.
Okay, go to the slides where you have shown the comparisons with the existing one.
Yes, sir. Here it is.
The last one where you have shown the figures, numbers, numeric comparison. Like this one, your one is better.
Okay, this one, sir.
Better.
So
See, whenever, yes,
Go to the
whenever
result
you,
section. Result section.
yeah, this is fine. This is okay. Let's say this is what is your output. So whenever
Yes,
you present a paper or in journal,
yes,
always depict it using graph, right? Graphs are
yes,
best to describe these type of things. Okay, so this is what I
yes,
found.
yes,
And other thing I
yes, sir. Yes, sir. Yes, sir. 99 above
so try
99%.
to try and anyway,
Yes.
any improvement is always welcome. So
Okay, sir.
over to Dr. Dilip.
Yes, Sayan, you are proposing an ensemble model.
Yes, sir.
So where is that ensemble model here in this table? You have mentioned the
Actually,
classifier separately.
yes, sir. Actually, sir, as we know that random forest classifier, descent classifier, and XRT classifier, these are the bagging algorithms. And into the ensemble model, there are three type of models like bagging classifiers and boosting classifiers and stacking classifier. So as I am using the descent classifier random forest, so that is why I use the term ensemble, sir.
Okay. Right.
Yes, sir.
Okay, thank you.
Thank you, sir.
I think there is no participant now. So
as we come to the close of this insightful conference track, I would like to thank this opportunity on behalf of the organizing committee and all the participants to extend our heartfelt thanks to all who made this session a success. First and foremost, I extend my deepest gratitude to our session chair, Dr. Sunil Gupta sir and Dr. Dilip Kumar Sharma sir, for
you.
their excellent leadership and for guiding the session with such clarity and professionalism. Your time and valuable contribution is truly appreciated. I also thank all the speakers and participants who shared their knowledge, engaged actively, and made this session meaningful. Once again, thank you all of you for your presence and participation. Wishing you a great day ahead and fruitful session in the rest of the conferences. Thank you.
Thank you.
thank you,
So
Dr.
may I
Sunil.
leave now? Thank you,
Yes,
sir.
sir. Thank you, sir.